You ever really stop and think about what's going on inside your computer? I mean, right now, you might be editing a video, browsing the web, maybe listening to music all at the same time. It's this incredible, coordinated dance of chaos. And right in the middle of it all, there's this unsung hero we barely even notice. To really get what it does, let's try a little analogy.
Okay, so imagine your computer isn't just a box of circuits. Instead, picture a super busy, high-end restaurant. You've got the kitchen, the chefs, demanding customers, a million things are happening all at once. So who's the one running the show? Who's making sure everything works together? Who is the general manager?
Well, that general manager, that's your operating system, or OS. It's the essential piece of software that's the go-between for you, the user, and all that complicated computer hardware. Its entire purpose in life is to take all that complex stuff and make it convenient, efficient, and, most importantly, easy for you to use.
And you know what? The analogy holds up perfectly. The hardware, we're talking your CPU, your memory, that's the kitchen and all its fancy equipment. The applications you're running, like your browser or your favorite game, those are the chefs, each one a specialist. You, of course, you're the customer placing the orders. And the OS, it's that manager orchestrating everything from behind the scenes.
So how does the day get started? Just like a restaurant manager has to unlock the doors and fire up the ovens every morning, the operating system has its own grand opening routine every single time you press that power button. This whole opening ceremony is called the boot process. It's the sequence of events that turns your computer from, well, a dead box of metal and plastic into the powerful machine you're about to use. The OS has to check all the equipment, wake up the staff, and get the whole place ready for business. It all kicks off the second you hit the power button. That jolt of electricity wakes up a tiny fundamental program called the bootstrap. Think of it as the night watchman. The bootstrap's first job is to do a quick inventory. Check that all the kitchen equipment is plugged in and working. Once it gives the all clear, its final crucial task is to find the heart of the operating system, called the kernel, and load it into the main memory. And at that moment, the general manager is officially on the clock.
Right, so the restaurant is open, and now the manager's real job starts, juggling everything. A customer needs a drink, a chef is yelling for an ingredient, the phone's ringing off the hook. It is non-stop. Your OS is basically the world's best multitasker, handling literally thousands of these little requests every single second.
So how on earth does it manage all that? Well, the secret sauce is that an operating system is fundamentally interrupt-driven. It's not just working through a to-do list one item at a time. Nope, it's constantly waiting for something to happen, waiting for a signal. And that signal is called an interrupt. It is exactly what it sounds like. It's a signal from either hardware or software that interrupts whatever the OS is doing and says, hey, pay attention to me right now. It could be you clicking your mouse, pressing a key, or a program finishing a download. It's a request for the manager's immediate attention. Think of it just like this. The manager is busy calculating payroll when suddenly a chef taps them on the shoulder needing a special pan. For just a split second, the manager stops, handles that one request, and then instantly goes back to what they were doing. Or, more likely, moves on to the next shoulder tap. And here's the magic trick. Because this happens millions of times a second, it creates this perfect illusion that it's doing everything at once. This is a concept called time sharing. The OS is just giving tiny slices of its attention to every single program so fast that it feels like every single one has its complete undivided focus. That's how you can have 50 browser tabs open while a game is running in the background.
Okay, so beyond just reacting to all those taps on the shoulder, the manager has three main core duties. It has to manage the chefs, it has to manage the counter space, and it has to manage the pantry. In our world, that means managing processes, memory, and storage.
First up, process management. This is all about deciding which programs, which chefs, get to run and for how long. Then there's memory management, which is like assigning each chef enough counter space, or RAM, to prep their ingredients. And finally, storage management. That's keeping the main pantry, your hard drive, so well organized that any file can be found in a flash. So, what do we actually mean by a process? Here's the best way to think about it. A program is just a file sitting on your disk. It's a recipe book on a shelf. It's totally passive, not doing anything. A process, on the other hand, is that recipe being actively cooked by a chef. It's the program in action, using up resources and actually doing something. Now, let's go back to that pantry, your computer's storage. A smart restaurant manager doesn't keep every single ingredient in a giant, slow-to-access warehouse out back. No way.
They keep the most popular stuff right up front where it's easy to grab. This brilliant principle is called the storage hierarchy.
This chart really shows the trade-off. At the very top, you've got cache memory. It's unbelievably fast, but also really small and expensive. It's like a tiny shelf right by the stove with just your salt and pepper. Below that is main memory, or RAM. That's like the main prep counter. Bigger, a little slower, but still fast. And at the bottom, you have secondary storage, your hard drive. That's the giant walk-in pantry. It's huge and cheap, but it's the slowest to get things from.
And the golden rule that makes this whole system fly is caching. It's simple, really. The OS is constantly intelligently copying the data you use most often from that big, slow pantry, the hard drive, and moving it to the faster prep counter and the super fast spice rack, your RAM and cache. That way, it's right there, ready to go the very instant you need it again.
A really great manager also has to double as a security guard. I mean, you can't have a rogue chef starting a fire or a customer just wandering into the main office. The OS has this critical job of protecting the entire system from chaos and also adapting to completely new ways of running the restaurant.
The main way it keeps order and prevents total anarchy is with a clever feature called dual mode operation. This basically creates a super strict boundary between the normal, everyday work and the critical, system-level commands that only the manager is allowed to execute. Here's the breakdown. All your apps, the chefs, run in what's called user mode. They can only use their own designated station and their own tools. But the OS itself, it runs in the privileged kernel mode. Think of this as the manager who has the keys to absolutely everything: the main freezer, the office safe, the circuit breaker. A program can't just go and mess with critical hardware. It has to ask the manager, who then briefly switches into kernel mode to handle the request safely.
And just like restaurants have evolved over time, so have operating systems. They're now built to manage all kinds of different setups. You've got the classic client-server model, one central kitchen or server, preparing orders for lots of diners. You have peer-to-peer computing, which is kind of like a potluck dinner where everyone brings a dish and shares. And of course today, so much of what we do is web-based, this massive global network of kitchens and customers all talking to each other.
And that kind of brings us to a final thought here. The operating system started out just managing a single machine, a single restaurant. But now these kitchens are everywhere. They're in our cars, in our watches, in our refrigerators. As everything gets smarter and becomes a computer, you have to wonder, what new, unbelievably complex challenges will this invisible general manager have to solve next?